Buenos dias. How's the sound today? All right. How's everybody today? Any questions about the material thus far? Otherwise, I'm going to continue with these notes, and I just emailed you some new notes. And I will tell you for the test that I'm going to send later today, I'm going to advise you where we stop the material, okay? I do want to have some basic some interest rate conversions problems on the test, which you should also know, but if you don't, you're going to learn this weekend. Good morning. No questions, no comments? So should we get into bonds? We're going to get into bonds. Now the interesting thing about bonds and the calculator, which we're focusing on right now, the interesting thing is that with bonds, we will use all the keys of the time value of money row. So keep that in mind. Yes, stock valuation is coming for the test. Yes, Sergio. We'll talk about that because we still need to learn growing annuity. Okay. So also, if you need to contact me, I already have some meetings with some students today. If you want some clarification, don't hesitate. Just text me. I can meet with you virtually and answer your questions. I can bring out the whiteboard, my iPad, and help you, all right? So don't hesitate. I'm not going to give you the answers to the test, but I'll help clarify anything in your notes. Okay. Okay, discount factors, Felix. I got some doubts with the discount factors and discount factor. You mean accumulation factor? How did I write it over here? Uh-oh, it sounds like they're starting construction upstairs. So if we're looking here, we have this accumulation function. I call this the accumulation factor. And here, this part is the discount factor. Let me write it out here. I call it a factor because we're multiplying by it. And when I talk about the discount factor, what I'm talking about okay, I don't know if that helps. Which chapters are we covering? For the text, it's 1, 2, 3, and 4. Obviously, not completely, but that's the background for what we're doing. Focus with the notes. The test is going to be like the pages that I give you, those kinds of questions. Annuity factor. In the annuity, okay, so that's discount and accumulation factor. So the annuity factor, they will refer to annuity so this is the new annuity formula. And if you're referring to the book and annuity factor, I don't know if it's just this part. Let me see. Hold on. Yeah, it's the whole thing. It's the whole thing. Yeah, so this entire thing here is called the annuity factor. And then you just multiply it by the payment. Any other questions? So the reason why they distinguish this factor is because before calculators were ubiquitous, before everyone had a calculator or a computer even, they had produced tables of annuity factors, and people would just take their payment and multiply by the annuity factor from the table. So that's how it was done. So they still have that terminology. Okay, I hope that helps. So that can be written different ways for different formulas, but you should realize it's the same thing. And I like to write it this way because, well, I have the proof of the origin here, and if you didn't understand this, take some time to review what I did there. Okay, good. And any other questions? So as I said, 3106 is the prerequisite for this course. So this is a review, and I am going in detail over this material, but you should know most of it already. And if you don't, you get the chance to learn it now. Okay, so let's see. What's a bond? Someone tell me what a bond is. Okay. Okay, so a bond is, a debt instrument. It could be a long-term. Okay, so if the person who purchases the bond, they're loaning money through that instrument. So they purchase a bond certificate or a bond indenture, and that represents their loan certificate. So they've loaned the money to either government or a corporation, and it could be for a long period of time. It could be short. When you think about treasury bonds, they're 3 months, so they can be as little as 3 month terms. So some of the features of a bond we'll talk about. Here's a problem and a timeline, and then we'll get into the features of a bond. Okay, so this is known as a pure discount bond. So this should look familiar. This timeline looks just like the regular time value of money, or the lump sum. This is the lump sum here to be received in 5 years. Whoops. So we know how to deal with that. Now, textbooks often use different notation for bonds, and I don't. I just don't think it's necessary, because we already have the notation. It's the same formula that we've always been using. This one pays $1,000 in 5 years. So what is it worth today if bonds of comparable risk have a yield to maturity of 6? What's the yield to maturity? What does that mean? So we did talk about this when we talked about the perpetuity and the bond, the console bond. Very good comments, thank you. So yield to maturity is like the return on investment, right? This is for bonds, this is our interest rate for our formula. That's right, Felix. And we say of bonds of comparable risk. Remember, because there are many interest rates floating out there, but this is the one that attracts us. This is the one we're willing to trade off our money for. So this is the one that we're going to use. We're going to purchase this bond as opposed to other ones of comparable risk. So we use 6%. What is the fair price? So what are we willing to pay? What's the most we'll pay for such a deal? If it was cheaper out there, we'd pay cheaper or less. But in the meantime, let's see. So we know how to do this. This is the basic time value of money problem. And I express that here is what I would put on my test. I don't have to put a timeline because it's not very complex for the test. I just have to enter that this is the basic time value of money problem. In my calculator, I put 5 as the years, interest as 6. Remember, it's a whole number. I enter payment as 0. There are no payments here. This is just a pure discount bond. It's called a discount because the standard is for a face value to be, so what's a face value? The future value, the face value, what you get at maturity. So you get back from the bond. This is called the face value. So it's still FV, which is convenient, but it also is the future value. It's what you're getting in the future. And that's what's written. These details are written in your certificate, that you're going to have this face value, the book value of the bond. But you're going to pay, when you compute the PV, you're going to pay this amount for it as a fair price, $747.26. It's a negative, right? Because this is out of pocket to get $1,000 at maturity. So we say the bond matures in 5 years. So there's just some language you need to know. Right. And implicitly, with the 5 years and the $1,000 face value, which I said is standard. So if you're not told about the face value of the bond, you assume it's $1,000. Okay? So if no one tells you, if a question doesn't tell you, you assume it's $1,000. And face value can be in reality even $5,000, but it's standard to use 1,000, and the text uses 1,000. Or it's usually 1,000. All right, so discount, because what does discount mean? It means that it's lower than what? The face value. Of course it is, because there is the implicit interest rate here, the yield to maturity. Okay, so in a test situation, all I want you to write is this and this. You don't have to put the formula down again. All right, so that was straightforward, just translating. I'm going to write this too. We call this yield to maturity when we talk about bonds. That's the most you're willing to pay for that deal. If someone offered for less, then it would be worth to buy it. You're getting arbitrage profit, it's called. All right. What about this? What if a bond has intermediary payments? So this bond is called a coupon bond, and it is a 5-year bond. Matures in 5 years, with paying a face value of 1,000. And in the interim, there are 6% payments, coupons or payments. So now we get to use the annuity formula because there's payments. So 6%, what does 6% mean? 6% of the book value, the face value, 6% of that means multiply 6% by 1,000 to get your payment. So this is what it looks like. It looks like, oh, Ruben, you want me to go back here? Sorry, I'm just going to interrupt for a moment. Ruben, what is your question? No, Ruben? It's okay? Okay. You want me to... So you guys can follow along in the notes, or you can take a screenshot. Oh, okay. You're done? It might be too hard to manage with notes as well as me writing, so I understand if you can't watch them both at the same time. Okay. Yeah, just take screenshot. So what we have in the coupon bond is this image. We have $60 beginning one period from today, and then every period, so in this case it's years, for 5 years, and then we get the face value as well, right? So we get our money back essentially for the loan, plus these payments throughout. So what is this worth? You're told that the yield to maturity is 6%. So the implicit interest rate is 6%. The coupon bonds are 6%. What is the fair price? Now, if you don't know the answer to this, you can use the calculator to solve it. But I want to go back to showing you that in this sort of a case where the coupon rate is the same as our interest rate or our yield to maturity. This is a special case. Right. If you put this in your calculator, so in the test you write this whole statement out, you will find, so what would you put in your calculator? You would put n is 5 in n. So from left to right, correct? So then 6 is the interest rate that you put into I by Y. I won't put the percent there because people might think they have to press percent. And then for payment, no, PV, you don't know what that is, so you leave that blank. Then you put $60 for your payment. And you're getting that, so it's a positive. And $1,000 for the face value, and that's positive, and you compute PV, and what you will find is you get 1,000. Does anybody have a problem with that? So it's saying that I'm going to pay 1,000 to get 1,000. Notice the formula is a little bit different because I have the lump sum amount, but I have an annuity for the $60 for 5 years. So I'm using the two different formulas for a bond. Now, students often forget this portion, so don't forget it as much as you can. Avoid it. Don't forget this portion. All right, so you're going to pay $1,000. This is the price. Or the fair price. You're going to pay $1,000 to get $1,000, but in the interim, you're making $60 a month. So this $60, not a month, a year, $60 a year. So $60 a year is like an interest rate of 6%, right? $60 every year is a 6% interest rate. So it looks like what's happened is the yield to maturity, or I, is being received not in the markup from the original price, not like the discount bond where you paid $747.26 to get 1,000 in 5 years. You're going to pay $1,000 to get this interest of 6% every year. So when these are the same, we have a special name for this situation. It's a very basic case. This is called a par value bond. So when you see those two numbers the same, you know that the price is just $1,000. What if it's different? What if the coupon rate that I've now introduced is smaller or greater than the yield to maturity? This is just repeating what I said with the keys on the calculator. So you will get the negative telling you have to pay 1,000 to get 1,000 and $60 every year. So what about if it's smaller? If the coupon rate is smaller than the yield to maturity, like without going into the calculations, what do we anticipate? we anticipate that we are not going to make all of our 6% yield with the coupon payment, so we should have some sort of a discount in the price. Let's check. Let's do the same thing we did before. The coupon rate is 3%. So it's important that you tease apart the coupon rate and the yield to maturity when you read problems, okay? Not to get confused. So the coupon rate is 3% and the yield to maturity is 6%. So a coupon rate at 3% means 3% or 0.03 times 1,000 gives you $30, and this is the picture. 30 every period, end of the period, and then your face value. At maturity, you get your money back. So, did you pay 1,000 for this? No, you probably paid less because you didn't make $60 every period, which would have been the yield. And it turns out that you do. You pay $873.63. The formula is like this, remember? You have the annuity piece for the payments and the regular time value of money formula. So this has a special name. It's called a discount bond when the coupon rate is smaller than the interest rate yield to maturity. In the calculator, let's try that. I'll give you a moment to put that in and confirm you have the same answer. Try that. Okay, good. Any other comments? Ready for the next one? So what we've done here is seen the impact of the coupon rate being smaller than the interest rate. Our payments are not enough to pay our interest, so we get a discount in this case. What if the coupon rate is greater? $7 coupon bond pays $1,000 in 5 years. So these are our variables. If bonds of comparable risk have a yield of 6%, this is what we should use as our discount rate. So they call it, it's an interest rate. Because it ends up on the bottom of our formulas, we also call it a discount rate. What is the fair price for this bond? This is our timeline. $70 every period. And then the $1,000 at maturity. So, what do you expect to pay for this? What do you anticipate? It's a 6% yield to maturity, but I'm getting more than 6% of 1,000 every period. So should I be prepared to pay more than 1,000 for that? The answer you would write out the formula. You have to write out the formula for the test, right? The formula looks like this: an annuity and a TVM. Don't forget the 1,000 at the end. And in your calculator, you enter 5 into N, 6 into interest. PV is what we want. Sorry. 70 into payment. And 1,000 into FV. So these are to be received, so they're both positives. And when you compute PV, you get the price Sergio tells us it's 1,042.12. Let's do it. So 5 into N, yield is 6. PV we leave blank because that's what we want to compute. 70 into payment and 1,000 into FV. So now we compute and we find it's $1,042.12. So the answer is in dollars and cents. Very good, Sergio. So, because we pay more than 1,000, this gets the name as a premium bond that you pay a little bit more than usual. This happens when the coupon rate exceeds the yield to maturity. Any questions? So some of you might feel uncomfortable that I'm just using the calculator and not calculating. Don't worry, you're going to have your opportunity. We're going to enter this into the calculator in the next set of problems. Not for bonds, but for something else. So for bonds, you use every key of the calculator, coupon bonds. And because we have those two components, we have two parts to the formula. The annuity piece and the lump sum. Next. All right. Now, we spent quite some time there, over half an hour, talking about finding the price of bonds. So those are the prices investors would be willing to pay given the information and knowing their risk tolerance. You know, the price they're willing to loan at, the interest rate or yield to maturity. What if they're looking at purchasing bonds in the stock market or open market, secondary markets, where bonds have been previously purchased and then resold? Now here's a bond that is, you're told, a 3% coupon bond which pays 1,000 in 5 years. So these are the terms of the bond. So let's say the bond was currently selling for $854.55. What is the yield? So you see that when bonds are listed, the details are listed, and this is the current selling price. This is available. Is it what would be the yield? Why do we want that? Well, if we're a prospective investor, we want to see what the yield is because we have a sense of what we want as a return on investment. And once we calculate that, we can determine if that's in our interest. So let's tease apart the variables. First, the coupon rate is 3%. That means $30 every period. Yield to maturity 1,000. We know the price. The price we are told is $854.55. Now for the calculator, you need to put a negative in there because the calculator keeps tabs on cash outflows and inflows. In this case, it's a outflow. So it is a discount bond, as Juan has mentioned. This is a discount bond. I'm paying less to get 1,000. Now, that's because there's the $30 in between. So without making any calculation, what do you expect the interest rate to be, higher or lower than 3%? You should be able to look at this and know that the yield to maturity is higher or lower than 3%. What would it be? Very good, Felix. Yeah. Oh, everyone, look at you guys. Very good. Sofia, Juan, Sergio. Okay, so it will be higher because you're told that this is the current price. So the yield to maturity, I will be greater than C for discount bonds, so I know it's going to be higher. Let's make the calculation to find out. Here is the formula with the annuity piece and the regular time value of money. It's very simple. I put 5 into N. This is what I want to calculate, so I skip it. I put negative 854.55 in PV, 30 into payment, and 1,000 into FV. So this is from left to right. And I compute the interest rate. So I leave interest blank. I put a negative there. The payment is 30 and the FV face value is 1,000, and I compute the interest rate, 6.5000. Very good. Let me know if I'm going too fast. Okay. So the answer is 6.5. All right, so we want to find a different variable. Oh, let me make a point. Wasn't that easy? So if you did this sort of a problem before using a financial calculator, you could have done it in Excel Excel has the capability with the rate function to do this, to solve this. It might get stuck. So you're supposed to propose a estimated rate. So it's really important to know this if you go higher or lower for than the coupon rate, to be able to put into Excel, if you guys have ever used Excel for this. I'm not using it. I did, I believe I sent you a list of Excel functions. Anyway, you can find them online if you really want to use Excel. So you would have to give it an estimate of a guess point so that it can compute without error or more efficiently, because it might not turn out an answer if it doesn't have a starting point. Because really what it's doing, it's not isolating I on one side. You can't analytically solve this problem. In other words, there's no analytical solution. The solution is derived by iteration. The calculator estimates what would be good and uses interpolation, putting in different values for the interest rate to approach this amount. Anyway, it's a different approach than what you're used to, solving an isolating I to solve for it. You can't do that here because you have this polynomial. Okay, do it again in the calculator. Let's do it again in the calculator. So 5 is N. Skip interest. PV is what we know is 855.54 negative, and then payment is 30 will be received, and also $1,000 at the end will be received, and we compute interest. Oh, I did something wrong. I think my PV was wrong. Let's do that again. PV is 854.55. Oh, wow, for a penny. Let's do that. 854.55 negative PV. Now, compute I. There's the answer. Just use the calculator, Eric. You just have to use the calculator. You have to write down the formula for me and just use the calculator. I don't need to see. It's too much work. I mean, it's not necessary. When you have a calculator, it's powerful to solve this for you. Are you happy about that? You don't have to do, you cannot isolate I to solve for it. It's impossible. By hand, manually. So I know some students are very resistant to using the calculator, but this is a 4th year course in the specialized area of finance. You should be using all the tools you can find. Manual calculations and capability of doing them is important, but sometimes you can't. So use your finance calculator or Excel. All right, what about the last variable? No, we also have to find time. So in this formula, we have, let's look at the formula again. So in this formula, okay, let's look here. Here's the formula. We have payment, yield to maturity, time. To find the payment, remember C1, right? It's 1 period from when you want to value it. Is the first payment. So it has all the properties of a regular annuity. So what we've solved so far is we've solved for PV, we solved for FV, knowing all the other variables, and we solve for I, knowing all the other variables. Now let's solve for C, the coupon rate. Now, payment is, remember, payment is C times 1,000 to find the payment. You take C times 1,000 to find the payment. So if you want to find C, you're going to use the payment. And then divide by 1,000 to find the C, the rate. So let's look at this problem where we have to find the coupon rate from the information provided. Here we have a bond, that's a coupon bond. And it pays 1,000 in 5 years, that's the FV. So you guys can look, this is FV, this is T. If the bond sells for PV of 900, so this is the PV, and the bonds of comparable risk have a yield to maturity of 8%. This is our I. What is the coupon rate? Where payment is equal to the coupon rate times 1,000, we need to find the payment. So here's our timeline with the price paid here, it's a negative cash flow, then payments, and then the 1,000 at the end. So setting up the formula you need to do for the test. Here's the formula, the annuity piece, and the lump sum amount at the end from the face value. And here's the price. So you write that out and then just go to your calculator. Now you could solve for this by isolating payment. You really could. We don't have to, okay? We're going to just enter 5 into N, 8 into interest, negative 900 into the price or present value. Payment is what I want, and I also fill in face value. So we use all the keys. Coupon bonds use all the keys. So let's do it. 5 for years. What's the interest? I have to go back. 8. 8 for interest. The price was 900 negative. Payment is what I want, and then it's $1,000 I get. Then I compute payment. So this is the payment to be received. It's $54.95, and I should keep some more decimal places. Depending on what I ask for, you have to read the instructions on the test. depending what I ask for, you have to provide that many decimal places. So say I asked for 4 decimal places. So it would be 549544. So I could say payment is equal to 549544. In the notes, I just keep 2. You have to follow the instructions. 4-5. Was it 4-5? No, 4-4. All right. Now, $54.95 is the payment. The payment is derived from C times 1,000. So I have to take I would need to take 54.95 divided by 1,000 to find C. I make it a small c. So that's why C is this amount. So you get the hang of it like a single digit rate, because you're multiplying by 1,000, results in a dollar payment between $10 and $100. So this will have a rate of 5.495. Okay, questions about coupon bonds? Now we've solved variables, every variable, present value, future value. We found the interest now and coupon rate. But there's one more variable. If we have all the others, if there's 5 variables. If we have 4, we could solve the 5th. Oops. Oh, maybe I don't have an example for time. We're missing time. That's interesting. I thought I had an example. Okay, so let me just make a note. So if you're given the other 4 variables, you can also solve for t. I'm just surprised I don't have that example. Take a screenshot. I'm moving on. Okay. So I guess when I prepare this, I was anxious to move forward with the last formula on your formula sheet. Annuity with growth. Here's an example of annuity with growth. And it is in the case of pensions. So Angel can purchase a product, a financial instrument known as an annuity. So you can actually buy an annuity. You can sell annuities too. To receive 30 years of supplemental pension payments beginning next month. These payments will be indexed for inflation. That means they will be anticipated to be 0.2%. Sorry, inflation is anticipated to be 0.2% per month. The prevailing interest rate, per month is 0.5%. What is the present value of this annuity? So, when problems are presented to you, the first thing you need to look for is the timing of payments. Now, a problem might not have payments, so you don't have to do this. But if there are, identify the timing of payments. So what's the timing of payments? Payments here are monthly. So payments are monthly. What it means is you need to convert all variables to the same timing. Okay, so that's all been done for you in this problem. The payments are monthly, so you need the monthly interest rate. The monthly interest rate, you're told, is 0.5% per month, but you're also told some other information. Inflation. Inflation will be 0.2% per month. What does it mean? Oh, and you're told about indexing. What does all this mean? It means that your payments will begin as $100 in this case, I don't mention it here, but here's the timeline. $100 to be received in 1 month, and then the $100 will grow, and that's to adjust for inflation so that you can afford to buy things, right? Because prices will go up as it's not going to be steady inflation, but we assume it to make our calculations. We assume it's going to be steady of 0.2% per month. We're spreading out the yearly effect by month. So we put 100 here, and then we say, well, it's going to grow by a growth rate of 0.2%. You have to be careful because 0.2% growth you'd have to put 2 zeros in front of it and 2. So you can write it like you write it as a percentage or a decimal. That's what it looks like. This should look, even though we haven't worked with such small numbers, this should look familiar. This is the same as, oh, well, let me show you. Well, I'll get into that in a minute. So you have the number of years you're told is 30. We also have to convert that. Since t equals 30 years, we need to convert that to months. So it's 360 months. The prevailing interest, Jose, is the 0.5%. That's not doesn't show up on my timeline. It's going to show up in the formula. So you have to get in your head the difference between all these rates, right? So in the last problems with bonds, in the bonds you had a coupon rate and an interest rate, and you need to know the difference. In this problem we're talking about an annuity where the payments grow. So we're talking about a growth rate. But we will use the interest rate to value this asset. So here is, okay, no, I'm going to skip over that. I'm going to skip over all of this and we'll go back in a moment. So this is the formula. Now it's different than the formula you saw before for annuity because there's growth involved. There's this extra term here, and there's this going on here. And then this is also important to discuss. So this looks different than the regular annuity because it's an annuity with growth. So we start with the perpetuity formula, but we use the growing perpetuity formula, and then we make our adjustment, right, to make it an annuity. This adjustment, this part, is different for growth where you have this extra term. Now, all the calculations prior to this were to prove where this formula comes from. So let's go look at what I did here. So this technique is really important to understand. Deriving these formulas is very important to understand at this stage in your education or career. This is the timeline for a perpetuity with growth, if you remember. C1 is the first payment, and then growth kicks in. 1 plus G, a factor of growth. And the growth continues up till T, but notice the exponent is 1 less. Why is it 1 less? Well, it's always 1 less because the first payment is in 1 year, and then the growth starts. So it's always going to be 1 less. Look here, even you imagine a 1 here, and the exponent, the factor, growth factor, is 1 less than the time. So if this was a growing perpetuity, this would be the timeline, and this would be the formula that we discussed, how it's derived. And if you don't remember, you can look back at the first few videos from last week. Oh, sorry, from the last weeks, I say. So what's this? Well, an annuity stops paying. It's not like a perpetuity that pays forever. So there's all these additional payments that I need to discard. Here they are here. Beginning at T plus 1, there's this amount. Notice I just continue with the growth. This would be the amount, and then it continues to grow indefinitely or forever. So I want to subtract all of these, and this is another perpetuity. This perpetuity starts at time T because the first payment is 1 period from there. So the formula for that would be taking this as my initial or my first cash flow. So notice I just copy that here and I use the growing perpetuity formula. So that's the first payment in the growing perpetuity formula. Now, this all starts happening at time t. So this amount is at time t, and this amount is at time 0. What I need to do is convert this by discounting the whole thing t periods. So I take this whole amount, discount t periods, and now I have this portion of the asset and this excess. This is like more than we're even going to receive. And I have to subtract these ones that will not be received from the perpetuity. Yes, I'll say this material is on the test. So where did the $100 come from? It doesn't say it here, but that's the payment. I guess it should say in the exercise. So this person's buying an annuity that pays them $100, that's indexed for inflation for 30 years. All right, so what I do then is I take this amount, subtract off those amounts that are not going to be paid, and I create my formula. You can see the mathematics here. It's just I factor out this and this, and I get 1 from this, and this leaves these amounts here. And then I make a point that we'll discuss in a moment. So this is the this is the annuity with growth formula, or growing annuity formula, and it corresponds to this timeline. Here is the timeline. This is on your formula sheet. This is at the very bottom. Now, I make a point, you should only use this formula provided I is not equal to G. What's wrong with I equals G? What happens if I equals G? Okay, Juan is asking, could you get a question with annuity due and credit? Annuity due with growth. Yes, you could also get an annuity due with growth, certainly. You have to create that formula for yourself. All right, so this looks very intimidating for some people. You're going to have to review it. Review it with this video if that helps. Essentially, this is the formula that's on your formula sheet. And we got to plug in our variables. So let's do that. And then we'll talk about I equals G. If you guys have noticed, no one answered that question yet. Why can I not equal G? All right, so let's put the values in. C1 is $100. I is, be careful, it was 0.5%, so 0.005. And G is 0.2%, so it's 0.002. And then I repeat them here, G and I plus 1. And then that number of periods. Now, how am I going to get this answer? Does anybody know? Is there a growing annuity formula in the calculator? No, there is not. Not in the calculator. And maybe it's in Excel, but I don't know that it's in Excel. That I do not know. We need to enter this calculation manually. Now, some of you will have the TI 83 or 84 calculator, and you can manually enter the whole thing. You can do it in Excel as well, just creating the formula. But I want to teach you how to do this on a finance calculator because I promised you that I would prepare you for the CFA exam, and all you'll have at your disposal is a financial calculator, and you'll have to use the scientific keys or the arithmetic keys. This is not in the TVM row. So how do we do that? Let's see. I am going to start with the calculation here. So what I'm going to do, I'm going to write out my steps and then go to the calculator. So I'm going to take 1.002 divided by 1.005. And then I'm going to raise it to the, I'm going to say equals. And then I'm going to raise it to the power of 360. And I'm going to say equals again. And that will give me this piece here. Then I'm going to change the sign to make it a negative, and I'm going to add 1. And I'm going to say equals again. Then I'm going to multiply by 100. Oh, I didn't have to write the dollar sign, but I'm going to multiply by 100, and I could say equals if I want, I don't have to, and then divide by 0.003 because I will have calculated on this side this amount. Now those steps will give you the answer. So that's how you use the finance calculator, the TIBA2 Plus, to do this. I think it's the same for the HP 10B2. And people with the TI-83 will probably just enter this a long way in their calculator screen. So let me know if you get it. Very good. Nice breath. Anybody else? So practice those steps. Now some of you will like to calculate this and write it down and then multiply, and it makes a mess all over your sheet, and you probably won't get the right answer because you need to keep all the decimal places. So really practice this technique. One other thing you could do is use storage. You could figure this out and then store that in one in case you lose it. And then multiply recall 1 times 100 and divided by 0.003 equals. You could do it that way too. You have to, yes, you have to solve it. Jose, you will have to use whatever calculator you have to compute this. So I suggest try now and see how you do. Let me know where you get stuck. So let me give you a few minutes break. Some people want to take a break. Take 5 minutes break. And we'll meet you back here and they'll check if you got it. So we can go backwards if people have questions about what I've already said. We can go backwards. All right, so I'm back. I don't know, I'll do this calculation with you. I don't know what else to do so we can move on. So I'm going to take 1.002, divide by 1.005, and equal. Then I'm going to take that to the power 360 months, and say equal. Now I'm going to change the sign. You see, I changed the sign, make it a negative, and I sum to 1, and I say equals. Then I multiply that amount by 100, and I divide by 0.003. Just follow the steps, and that's my answer. So you should practice that, because either do it there or put up the formula in Excel so you can get your answer. Okay? All right, one last time. Let's do it again. So, clear. So 1.002 divide by 1.005 equals. So that is the inner bracket. Then I raise to the power 360. I use y to the x 360, and I get this amount equals. So now I'm going to be in the big square bracket. I'm going to change the sign and add this to 1. So now that is the content of the entire bracket. Now you could store this if you want in case you make a mistake later. So I've stored it in 1 in case I make a mistake. And then I multiply by 100 and divide by 0.003 and say equals, and that's the amount. Okay, good. Let's move on. So this is, okay, so the last question I have for you was one of the first questions I had. Why is this the case? Why is this condition? So remember, each formula has conditions. Remember, for the annuity, let's go back and see what I wrote back here about annuities. Oops, and the conditions. Okay, we did this today. All right, so annuities, that's perpetuity. Okay. Remember this. When I first introduced annuities, and first cash flow must be in one period. The cash flows must be the same. And they're not infinite, but finite, right? There's a finite number of cash flows. But for the growing annuity, we have to add some points. So let's take this with us over. Actually, I'll just take these and write in the finite piece. Do that again. Let me fix this. So this was from, remember it said infinite because I adjusted the perpetuity formula with this amount, and I explained. Let me erase this annuity factor comment too. So this was the perpetuity, and then we multiply by this. So this amount is like, this is the adjustment from the perpetuity that was made with the logic that I used earlier. You know, over here, these formulas. Okay, so I'm going to take this with me just to make a strong point. What just happened? Do that again. What are the conditions for this formula? So we have the formula here. Let's put them down here. So it's like an annuity. The first cash flow is in one period. Cash flows are the same. That's not true, right? We got to change that. Cash flows. I'm going to add the word grow at the same rate. Cash flows grow at the same rate. So they are not the same, but they grow at the same rate of G. What else? Growth begins in second period. That's really important. So the conditions are first period, first cash flow 1 period from now. Cash flows grow at the same rate G. And the growth begins in the second period. So only with these conditions can you use this formula. And the last condition is that I cannot equal G. So why can I not equal G? Right, Felix and Misael. It's that we would be dividing by a 0. That makes no sense. And notice also, what would this become? What would become in this bracket? What would we have if I was equal to G? This would be 1. Okay, Felix, I'll get to that in a second. So Misael said 1. Right, so this would be 1, and then you would take 1 minus 1. So what would you get? You would get a 0. So you would have 0 times anything is 0. So you would have 0 divided by 0. That is not meaningful, right? 0 divided by 0 is not meaningful. This formula does not work, okay, if I equals G. However, just because this formula doesn't work if I equals G, it does not mean that there is no answer if I equals G. If I equals G, you must use first principles, and I'll show you how. I have an example here. There will be an answer. So make a note that you can only use the formula if I is not equal to G, but note no, I shouldn't use caps. If I equals G, just use the timeline to help you solve it, okay? And I'll show you an example. So that's to be continued later. All right, so we've calculated this. Oh, sorry, do you want to take a screenshot? Why there will be an answer because, well, you're going to have cash flows that you need to account for. It's just that G is equal to I, and this formula doesn't work for you. And we'll see that example here. So what if I equals G? Here's an example. You're considering a deal where you will receive $100 cash flow for 4 months, starting next month, and each month thereafter the cash flows will grow by 1%. What would you be willing to pay for such a deal if the effective monthly interest rate is 1%? So this is the timeline for this problem. Same as before. First step, identify timing of payments. Sorry. And step 2 is, so the answer here is monthly. Step 2 is convert variables to months. I'm making the point now. You have to do that in every problem, okay? If there are no payments, you don't have to do this step. So you are considering a deal. Okay, so this is the timeline. So this is growth. It's a growing annuity, but I can't use the formula because I is equal to G. So what do we do? Let's take the timeline here and let's use a mixed cash flows approach, right? Use a mixed cash flows approach means, well, I could do this with NPV in my calculator, but let's just do this to see if there's a pattern. Okay, so the pattern would be that this $100 would be discounted 1 period. Now this amount would be discounted 2 periods. And this amount would be discounted, sorry. And this amount would be discounted three periods. Are you with me? And this amount would be discounted 4 periods. So remember, there's growth, so those are growing. They're going to be larger numbers. So this, I leave it with the brackets. Like this is going to be $101, right? But I leave it in brackets because I just want to look for a pattern. All right. I'll just make a note. You don't have to calculate them all. You don't need them. This would be 101. This would be 102.01. This would be 103.03. Okay, but there's also decimal places here. Anyway. So I don't need those numbers. I'm going to stick with the brackets because look at this. You see this pattern. There's a pattern here that one of these down here cancels with the top factor, accumulation factor or growth factor. And these two will cancel with two of those. And this should be a 3 here, sorry. Got carried away. This one is 3. And these 3 here will cancel with 3 of those. And what does it leave? You see the pattern? This leaves right, because 2, there's 2 down here and there's 1, so it leaves 1. And then over here, there's 2 on top, and that cancels with 2 on the bottom, and that leaves 1 on the bottom. And then here, it's going to be 3 on the top cancel with 3 on the bottom, so it leaves 1. So what do we have? Suddenly, we see that basically the growth and the erosion factor, the growth in the numerator, with the erosion factor canceling in the denominator, leaves the same term. They basically offset each other. The growth is offsetting the erosion factor of the time value, the time value of money. So the final answer is that PV would be equal to 4 times 100 over 1.01. And from there, you can have a general formula. In general, you could say, did I write it here? So here I have it printed out neatly for you. Here is the formula, or the final answer, 396.04 on page 80. So in general, when this happens, when I equals G and all the other conditions are met, the price would be, or the fair price would be the duration times C1 over 1 plus I. So you can put this on your formula sheet. You just need to remember the conditions. You could put them, you can put it all over 1 plus I if you like. Or maybe it'll be better if I write it like the way, whoops. The way it appears in the derivation. Okay. Next problem, and I think we're almost done. So here's another application. This is, oh wait, somebody had a question. Let's see. Okay, Felix asked, what happens if I have the first cash flow in 6 months and all the others in 1 year? You need to make a timeline, and you need to, so when things are not exactly, when you're not able to exactly apply the formula, as I just demonstrated, you need to make the timeline. You need to identify if there's payments and the timing of payments. Convert all your variables to the same timing. If it's monthly payments, you need monthly rates, and you need your time or duration in months. And then you would calculate all the pieces 1 period before the first cash flows. Then you would discount them all to time 0 and then sum them, just like I'm doing in these exercises, in these derivations of the formula. You'd have to do something similar to what I've done there. I'm trying to find one like this. Right, so lay it out, identify where you have cash flows that you can summarize, and make adjustments so you can add that at time 0. So that's just an example. What I've been doing so far is how you would handle new cases where the formulas that you currently have do not apply perfectly. All right, so what about this case? A pension problem. $3,000 per year are deposited every year at the end of the year for 30 years. You're guaranteed 12% per year return, which is very high, but in fact, you could, and we will talk about it, if you look at returns on the stock market, so you think of this as maybe a 401k, on average, the return is about 11% in the stock market. Now, in any given year, it could be there could be a stock market crash, and that's happened a few times in the last 10 years. But overall, on average, it returns about 11% a year. So I've just put 12% per year here to mimic what you could get if you were investing and then just leaving your money there for 30 years. So each year that you deposit, you will have accumulated interest on your previous deposit, but then you're adding an extra amount. And to deal with this problem, the growing annuity formula can help us. With the first payment in 1 year, that means we can use it just as it is. And actually, there's no growth here, sorry. We're just going to use a regular annuity formula, right? There's no indexing or anything like that. This is actually, as complex that may appear, this is a most simple case of a pension problem where I'm depositing $3,000 a year for 30 years, and then at the end of 30 years, I will start withdrawing. So I'm going to deposit into a fund $3,000 per year for 30 years, and earning 12% throughout this whole time, and then withdrawing. And now with each withdrawal, the remaining deposit still accumulates interest. How are we going to take care of that? Well, still the annuity formula can help us. So how do we do this? How do we deal with this? Well, these cash flows going into the pension will accumulate and we'll get the future value at time 30, right? Now we don't have we don't have a future value formula for annuity. This is an annuity here because there's payments. There are payments. So I'm going to demonstrate how we deal with that. So that's for the deposits. For the withdrawals, we have so we're here at time 30 now. We're sitting here, standing here, and we're going to accumulate this to time 30, and then we're going to look forward. And looking forward, we're going to treat this point in time as the present value perspective of what's to come. And what's to come is that we're going to withdraw from this fund. So notice at any given point in time, I could look backwards and say this is the future of what was, previously at time 0. Or I could look forwards and say, this is the present of what's to come. So actually, when I write this down, the future value at time 30 is identical to the present value at time 30. So we're going to use that to deal with the annuity on this side. There's also an annuity on this side, but now we're withdrawing from the fund. How we differentiate is that these are cash inflows going in, and these are cash outflows. Going to us. All right. So let's deal with this. So this has 2 parts, and many of the problems that are more complex have 2 parts. So here is the first part. We're going to deposit into the fund $3,000 at 12% for 30 years. In your calculator, you will get this amount. So let's do that together. 3,000 for 30 years. We're going to deposit 3,000 at 12%. So I put 12 in here. And the PV is what I want. The payment is 3,000. I can put negative. And FV, I put nothing in there because we're not dealing with bonds. That one is just, I give a place mark of 0. So then you compute the present value. So that's the present value amount that are in the notes. That is in the notes. The notes say 24165.55. And I got 2,4,165.55. Now that's the present value, but I'm not interested in the present value. I want the future value. I want to know how much has been accumulated. So I compute the future value. Something's wrong. What did I do? Do that again. 30 periods, interest is 12. I include the present value amount is what I want. Sorry. The payment is 3,000. I know what I did. Negative. And then I compute the PV. So let's say instead of PV, I want FV. For this answer, FV needed to be 0. Let's do that where I put 0 into FV and I compute PV. This is what I get, right? But now I want to get FV out of my calculator. So I'm going to superimpose a 0 in PV and then ask for FV. Now this is the future value, not the present value. This is the future value accumulated amount in the fund. 723,998.05. So how did the calculator do that? Well, if I put 0 into FV and ask for PV, I'm getting the present value. This is the lump sum amount value. This is the value of those future payments. Okay, so if I'm to deposit the payments, I want to know what they're worth. That's a different question. This gives me the answer if I was to this is like, what is it worth today? Or you can think of it backwards. You can think of it, if I was to receive $3,000 for 30 years, this is what it would be worth, or fair price to receive. So that's not the question. The question is, what does it accumulate to? So that's why I put a 0 in PV and I ask for FV. So in the notes and in a test situation, you would have to write the PV part and then accumulate for 30 periods to get this amount. So this is what the calculator is doing when you put a 0 into PV and ask for FV. It accumulates the amount that you had at PV. The present value amount accumulates for 30 periods, giving you this amount. So it's quite big. It's a $750,000 are accumulated, and this is a good incentive to start saving as soon as you can. But 12% is a very high rate, and as I said, it's 12% on average. Historically, yes, that's true, but if you're investing over a 10-year period and it's a low return period, it can look really bad. You just got to hang in there and leave the deposits there to realize this 12% average return a year. So, what do I see? Now, I have figured out that this amount here, looking forward, it's $750,000, and I want to withdraw now an amount. So the question is, how much can I withdraw? So here's the answer. I can withdraw payment where I see this as an annuity for 20 periods in the future. So this is the second annuity, but now I'm looking for C1, not for FV or PV. So what I did, the trick is to rename future value as present value and use the annuity formula to solve. So how do we solve this? Now I'm going to enter this into my calculator with this amount that I have as the future value. I want to put that into the present value amount, and I want to ask for the payment. Now you just have to be careful about the signs. Remember, we have to keep our signs as cash inflows are positive and outflows are negative. So how does that happen here? So here's my future value amount. I'm going to store that in 1. So it's there. I'm going to clear my screen and I'm going to say, well, the N, now it's going to be 20, right? So it's 20 periods of withdrawals. Still, we're going to imagine the prevailing interest rate as 12. This is what we're using. This is what this is our return on investment. For the remaining deposits, we assume. And then our PV is what we don't want PV. PV is what we have. So I'm going to recall this amount here, and I'm going to make it a negative and put it in PV, because when I ask for payment, I'm going to put a 0 in FV. I'm going to ask for payment. The payment comes out as a positive, just so it's less confusing. But it wouldn't matter either way, as long as you understand your result means that you can withdraw $96,927.98. Should I do it again? So this is the amount that's accumulated. It's a large amount. It's $750,000. I'm going to put that into my fund. This is the fund that I have, but I'm going to make it a negative, as though I'm saying I'm going to, like I basically paid that, right? So that was cash outflows that accumulated, but basically that's in the fund now that I'm going to withdraw from. So for 20 years, I'm going to withdraw with a prevailing rate of 12%. I'm going to put a 0 in here because what I'm interested in is the payment. So all I really need to change was the N from 30 to 20 and override the future value. Instead, put my amount into the present value. So I flipped from future value to present value. So those steps are included here. And all I need to add is, so you'd have to write this formula for the second part and your result. I stored it and I recalled one here, but I said to make it a negative, so let's put that as a negative here. So that this one comes out positive. If it comes out negative, it's fine too. You just don't write that down. You just write down the value and say that's the size of the payment starting at the end of the 31st year. Questions? Okay, no comments? All right. I can talk about this later because that will take some time. Okay, so what remains? Okay, let me ask you, in terms of the Connect problems, do you feel prepared to answer the Connect problems, or do you feel that you need more time? Okay, so I can give you more time for the Connect problems. I'll give you till next week. Okay, so I'll change that till next week, before class. Or maybe one whole week. I'll give you till next Sunday. Okay, so for the test, let's look at some problems that I gave you to review. I need to give you the test because I need the grades to submit the grades, but the test will be on this material, so you guys can focus on this material for this weekend. What I want to do is look at some more problems. All right, so I gave you some exercises to try. Sorry. And I gave you the solutions, right? So were there any problems here? Did anybody have any problems with these? Actually, you know what? I'll open the clave up. Let me open up the clave. Did anybody have problems with any of these exercises? Any questions about these? So they were very simple problems where I introduced the mortgage and I had some net present value exercise, and then there were some stock valuation problems, very basic. So no questions about that. What about the annuities? Okay, so here, what I want you to do in these exercises, I give you the answer, and I ask you to solve these as an annuity. I mean, maybe you didn't figure it out off the, immediately, but I did mention to you, you need to solve these as annuities so you can follow my clave. So I want you to solve this as an annuity. This is in 5 years, it says, for 5 years, you'll be able to receive $1,000, but the payments begin in 4 years. What is the current value of this stream of cash flows? So if this was a deal, what would you be willing to pay for that deal? This is my timeline. So that's not really going to work, right? Because it's much more time. So start at the 4th year with $1,000. And then pay for 5 years. And that's about it, right? So we're going to have 1,000, 1,000, 1,000. So this is the timeline. And I want to solve this using an annuity. I don't want to use the net present value rule and my CF keys or whatever people are using, because I see students writing out long expressions and it's not necessary. What we have is a set of cash flows beginning here. Year 4. 1, 2, 3, 4, 5 until year 8. So the formula that I learned, or that you learned, says 1 period before the first payment, I can find the value. So in time 3, I can find the value of this as an annuity with $1,000, 8%, using the formula of five payments. So there you go. So that's the formula that I write down. Or you could write it like, maybe you're used to writing it like this. Okay. And all you have to do is enter this into the calculator. So 8%, 5 periods, 1,000. We say 5 periods, 8%, 1,000, and I don't want FV, I want PV. There you go. 3992.71. And I need to take all the other decimals with me, so what I'm going to do is store that in 1. So it's stored, and I'll store it as a positive to avoid confusion. So 399 to 0.71003 or 37. So this amount is 3997.0037. Is that what it was? Oh no, 99271. What am I doing? 3992710037. My memory. So I just showing you that, like, you don't have to write out all these decimals, just, you could even write 3992.71 just to remind me that you stored it, to let me know you stored it somewhere and not lost the decimals. Now, the question asks for the value at time 0. So what you need to do is discount that. So this is a lump sum. All of these cash flows together now are worth $3,992.71 and some cents at time 3. So I need to get the value at time 0. So I say by PV0 is equal to that amount, I just call it PV3, discounted for 3 periods. So 3 and 3 have to be the same to get me back to 0. So 3 periods of discounting that lump sum gets me back to 0. So do I have to actually divide that? Well, I could, or just go back to my calculator and use the basic time value of money approach. Back in my calculator, I clear the screen and I say now it's 3 periods. I want to discount at 8%. The amount that was in my calculator, I don't have any payments and I'm not interested. Oh, sorry, I'm interested. I'm going to call that the future value, not the PV. I'm going to put this recalled amount into the future value. And then I'm going to ask to compute the present value. So that is the final answer. So you should be using your finance calculator at this point. You need to practice with it. I don't want to see on your solutions, I don't want to see solved step by step with calculations. We are beyond that. If I do see that repeatedly, I may penalize you. I'm not interested in the final answer. Well, I am interested in the final answer, but I'm saying I don't want you to get the final answer only. I want to see the process. I want to see that you've used the financial calculator efficiently. Oh, questions, comments? No? So we do have the final answer. I'm going to round at 3169.54. And I can circle my final answer like that. Next problem. Do you want me to do the next problem? Next problem. Starting 1 year from now, we will receive $2,000 for each of the next 3 years and $3,000 for 2 more years. All right, let's make a straight line using this. I'm going to make a straight line. That didn't work. And so this is what you should do until you get the hang of this. So it's going to be $2,000 for the next 3 years. And then $3,000 for 2 more. And I can erase this last year. And my timeline. So I want to solve this with annuities. And what I have is one annuity here, and I have another annuity here. Now, why did I go one period before? Because remember, the formula gives us the valuation one period before the first amount. So this amount we'll call, this will be at time 0, but we'll call this part A. This is easy, right? So this is just the annuity with 10% for 3 periods, duration of the investment. And we can calculate that with the calculator. Three periods, 10%, $2,000 payment, 0 into FV, and you compute PV. So let's do that. So 3 into N, interest is 10. The payments are 2,000. I don't want FV. I'm going to compute PV. All right, so that's the amount that I put here. I can just store that in 1. So I change the sign and store it in 1. Next, this amount, the 3,000 beginning at year 4, will be priced with the formula at year 3, one period before, and I'll call this B, and this is $3,000 for 2 years. So let's do that now. So it's going to be 2 periods at 10% with the payment of 3,000, nothing FV because I want PV. So that is the PV. What I found is the valuation at time 3 of these $3,000 deposits or amounts. So this is worth 5,206.61157. And I store this, I'll change the sign and store this in 2. And I have to write it on my page because I might forget. Now what? Am I done? No, because I need the value of this amount over here. So this is now a lump sum of $5,000, and I want to get the
value at time 0 of this amount. So I just write this because I don't want to rewrite the whole number. And this will be at 10% for 3 periods. Again, 3 discounting periods will bring me back to time 0. So I'm going to take, let's just be clear, I'm going to take this amount well, actually, I'm going to take this amount back. And what do I get? Let me leave some room for my answer. So that's in storage 2. So what I want to do is for 3 periods now, I want to discount at 10% the recall 2 amount as the future value with no payments to find the present value. So let's do that. So what I want to do is for 3 periods, I want at 10% to, with no payments, recall number, oh, it's not in here? Oh, I never put it. Did I not do it? I have recall 1, but not recall 2. Okay, I got to do that whole sum first. All right, so 2 periods, I thought I did it, of 10, at 10%, I'm going to ask for $3,000. I don't want FV, I want PV. So this is the amount, and I store it, well, I change the sign and I store it in 2. All right, now I want to, back to what I was doing. So that's this amount here. And now I want to discount it, and I want to add it to recall 1. So let's do that. So I want to take that amount, recall 2, and I want to put it in FV. I want to take that amount back for 3 periods at interest 10% and put no payments and ask to compute PV, and there you go. So this is really what I want, but I'll call it store 3 in case I make a mistake somewhere else. So what I'm doing is I'm going to store this amount in 3. I always get the positive versions because it can really complicate things if you forget that you have the negative version stored. So this would be okay, so I'm going to take this amount back 3 periods. So I'm going to recall 2. Sorry, I'm going to, for 3 periods at 10%, no payments, enter my second amount into the future value and ask for the present value, change the sign, and store it in 3. So this is the discounted second annuity. Now I want to recall 1 plus recall 2. No, sorry, not recall 2. Recall 1, and I want to add it to recall 3. And that is not right. So what did I do wrong? Hold on. Did I do something wrong? Let's do it again. 2, 3. Oh yeah, it works. So now you want to add these together. I don't know why it didn't add. Okay, so this is the first amount. This is the second. So what I want to do is recall 1 plus recall 3 is my final answer. In other words, I'm taking PV0A plus PV0B. Recall 1 plus recall 3. What's wrong with my recall 1? Is something wrong with it? What happened to recall? I must have stored something wrong. Let me do 1 again, because I have everything right here. I don't know, I must have overwritten it at some point, sorry. So let's do this part again and put it in my calculator. It should be stored in 1. 2,000 for 3 periods. So 3 periods, 10%. %, 2,000, asking for PV. Change the sign, store 1. So that's the first amount, and I'm going to add it to recall 3, and we get the final answer. Questions? Any comments? Any comments? No comments? All right, so that's that one. And then I give you this problem with annuity due for you to practice whichever method you choose, and I give you the clave on how to do that. So, any questions about this? $1.5. Any questions? I'm just looking for my clave. I don't know why it's not here. Yes, stock valuation will be on the exam. So no questions about the annuity due solutions. What about this one? Are duration exercises coming in the exam? You mean for bonds duration? No. But duration of an investment? Yes. Okay, do you want to work on these? I guess we don't really have time left, but what I can do is I can share a video. If you go through all my videos in this time, in this live stream, if you go through my videos, you'll find what you need. Everything is solved there. Maybe I can share with you the video that describes this one so I don't have to stay online right now. How about that? Then we can get going and you guys can watch that. Or would you like me to begin with this? Because I have no problem beginning. Just don't know if you're going to stick around. Only 15 of you are left here. Should I continue? Or should I just send you the video? Yes, continue, or yes, send you the video, Juan? I'm not sure what yes means. Okay, so let's stop here and I'll share the video. I'll send it by email. And for people who aren't here, hopefully they understand it's important. Sophia wants me to continue. You want me to continue? I mean, I could reproduce this here. You guys can leave and I can just leave the video here and you can come back here. Let's do it like that. I'll continue. I did have a meeting with a student, but I'll have to postpone. So I'll do this here in this video. If you're here or not, I will continue, okay? Those of you who have to leave can come back and watch the rest afterward. Okay. All right, so let me just make a note to So I have to postpone my meeting. Okay, so let me continue with this, with your group. Let's do this. I like even when one person wants the answer. All right, so if anyone has to leave, goodbye. I'll just continue. I will send the exam tonight, and you have until Sunday at 3 to complete. Hey, have a good weekend. Who's leaving? Okay, so let's do this. All right, let me make a straight line. Suppose the nominal discount rate is 8% and the expected inflation rate is 2%. So we have a situation where we have a growth rate, 2%. Determine the present value of a 6-payment annuity of $1,000 real cash flows per year. The first payment is in 1 year. Real cash flow. So this is a concept that you need to know if you don't already. A real cash flow. Every cash flow so far until this moment I've dealt with is known as a nominal cash flow. You assume that cash flows are nominal unless you're told otherwise. So what is the relationship between real and nominal cash flows? Well, it depends on inflation. I'm going to use the notation cash flow. Oops. So C is the cash flow. Nominal. At any given time t is equal to the real cash flow adjusted for inflation. Okay, so this is nominal. And this is real. And I use the subscript t because it's for any point in time. You have to use a growth factor. This is a growth factor of inflation. So what is inflation? It's price rises over time, and we're not going to get into discussing why and how that happens. We need to be aware of it in finance and hedge against inflation by indexing. For instance, we talked about pension funds being indexed for inflation. If you're going to save money so that you can live on money in your retirement years, then you want to make sure those payments are adjusted for inflation, and that you've taken into account that you have to put a little bit more as well while you're saving for the fact that prices will rise. So you want to work in inflation. You want to be able to be investing at a return that's bigger than inflation so that you beat inflation, right? Anyway, so that's a consideration you need to make. For now, until now, all that I was dealing with was always nominal. Now we're going to talk about real. Okay, so real. What the heck is real? I'm going to draw this timeline and then we will talk about it. So, I'm going to do it in black. So there are 6 payment annuity. All right. So they're going to be $1,000 real cash flow. So I'm going to make a note here that these are real cash flows. And it looks like a regular timeline. I'm going to put 1,000, 1,000, 1,000, 1,000, 1,000, but these are real dollars. What it means is that based on time now, you're going to get the equivalent purchasing power of what $1,000 buys you today. So if $1,000 buys you a laptop today, you should be able to buy a laptop at the end of the year. You should be able to buy another laptop at the end of the second year. You should be able to buy another laptop at the end of the third year. Now, obviously, laptops, they might go up in price, right? Okay, let's say laptops are strange because, or computers are a little bit strange to think of. Let's just talk about, you want to be able to buy, because it's 1,000, that laptop would be good. Let's say you want to be able to buy the equivalent of $1,000 to celebrate your birthday party. So you're going to use $1,000 for all the preparation for your birthday. So every birthday you want to spend $1,000 worth of, you want to be able to buy or purchase $1,000 worth of supplies to put on a birthday celebration. So this year, $1,000 will buy you everything you need: the hats, the banners, the plastic cups, the paper plates, the cake. Anyway, all the decorations, the hall. Let's say you're going to rent a hall. All of those things that go into preparing a celebration. You want to be able to have a celebration every single year. So you want the equivalent of the celebration costs. All right, so that's what real means. It means it reflects the base year purchasing power. And the first thing you want to do with this is change it into nominal so we can understand it a little better. Maybe this makes us more comfortable. I don't mind real because I understand what it means, but some people feel uncomfortable. Okay, so let's convert those right off the bat to nominal. I think it's pouring rain outside. I need to look because it's distracting me. Oh yeah, it's pouring rain. Okay. All right, so what I'm going to do is convert these to nominal cash flows using the relationship I described above. So what would be the conversion? So if I don't have anything in the first year, but if I did, it would be the same amount. So from real to nominal, notice if I put a 0 here for time, no time passes, nominal and real are the same. For the first year then, let's adjust it to nominal cash flows. Let's figure in inflation. So this amount will be 1,000, 1.02, and that's what it would be. So it's going to have to be that I have this amount, right? So real cash flows of 1,000. The annuity would pay me 1,020 at the end of year 1. At the end of year 2, it would be 2 periods of inflation passed. So this looks or feels familiar because these are growing annuities. So this is 1,040 and 40 cents. Okay, so a little bit more cash in your pocket if real cash flows stay the same and there's inflation. That's essentially what's happening. So I'll spell this all out. You can let me know if you get the same numbers or if I make a mistake. Okay, so this would be 1,000. Etc. etc. Okay. All right, so the question asks, determine the present value of a 6-payment annuity of $1,000 real cash flows per year. The first payment is in 1 year. So this is the timeline for real cash flows. This is the timeline for nominal cash flows. In this first question, I'm asked to use the real cash flows here and the annuity formula to calculate the present value. In the second part, I'm asked to show how to get the same result, because you should have the same result, whether you're using this timeline or this timeline. So something needs to change in my approach. In fact, what changes is this timeline is a regular annuity, but this timeline is a growing annuity. The catch is, the trick is, that your discount rate changes. If you're going to use this, you need to use what's called the real rate of interest. I'm going to make a note in black. So I'm going to use interest and discount interchangeably. This is the real rate of discounting, or I'll just call it interest. What the heck? Real rate of interest. Okay, so for real cash flows, you have to use the real rate of interest. Now you're going to say, what is that? Well, until now, all we've done is use the nominal rate of interest. All the rates you've seen have been nominal. When you deal with nominal cash flows, you have to use the nominal rate of interest. So what I need to teach you next is where you find these rates. Now, which rate was given in the question? The question gives you a nominal discount rate. Aha. So this we have. And this, inflation, I will use a symbol, standard symbol for inflation is the pi symbol. Oh, sorry, let me fix that. I'm going to call it 2%. All right. So far I've talked about cash flows being real, converting them to nominal so we understand their purchasing power. Well, actually the real ones give us the purchasing power. That's the equivalent of $1,000 every year. And here I'm translating them into actually what I have to have in my pocket in the given year to be equivalent to 1,000 real dollars and up here. So that's, I related them using this formula. So that's how I created that. Now I'm asking, what is the real rate? How do I get it from this information? So you need a second formula. So the first formula was just checking. Yeah, no, it's just like that. Okay, Fisher relation is that the nominal rate accounts for the inflation, but I have to use factors, right? These are growth factors or rates. So I'm going to say Fisher told us that this is the relationship between real and nominal rates. All right, so we've been using the nominal rate all along until now, and hidden in there is the real portion. This is the real rate of borrowing and lending. This is the opportunity cost of borrower lending determined in capital markets, or yes, in the finance sector for whatever kind of asset you're interested in. And this is the inflation factor, okay? So this is Fisher relation. This is the second formula you need. And there's one more that's coming, but it will be in the second question. All right, so what do we have here? We have first to solve this problem, part A, with the regular annuity and the real amounts using the real rate, which we need to calculate. And in part B, we're going to compute the nominal, the growing annuity using the nominal amounts, because this is a growing annuity timeline, right? And you will use the nominal rate. So what I'm going to ask you to do is try that on your own, and then I will do it. So let me give you a moment. Let's first do part A. Let me write the formula out. I'll make some room. So for part A, the present value at time 0 is the regular annuity with $1,000 and the real rate, right? I'm just going to put in the symbol for now, and we're going to make the calculation. Now let me tell you something before I continue with using this formula. You would have learned about inflation in economics, and you were probably told that the nominal rate of inflation is just the real rate of inflation. Sorry, the nominal rate, I hope I've been saying that all along, the nominal discount rate is equal to the real rate plus the inflation rate. I hope I haven't been saying the real rate of inflation. No. Sorry, this is the problem with live stream. So nominal rate is equal to the real rate plus inflation. And you've learned this in economics as this is an approximation when inflation is small. But when you get larger inflation rates, it's a little bit off, and your results, so this means approximation, let me write that. Your results are not precise, not like what you're going to see here. Oh, did it freeze? Hold on. Ah, it froze. Hold on. All right, I gotta go back. We lost just a minute, but you didn't get the Fisher relation. Okay, let me do that again. I have to reconnect. Sorry. Maybe if that happens again, I'll leave my phone on. It's a debate. Okay, sorry, I just got distracted. So you see that now? Did that work? Nope. My connection is broken. All right, so let me erase what I have here. I turn my phone on. If something happens again, just someone text me. I might or might not see it, but I'll repeat what I said. I need to erase all this. All right. Anyway, I don't mind explaining it again because I think I might have misspoke. All right. All right, so what I was saying is that there's a relationship between real rates and nominal rates. What you have been given is the nominal discount rate. So what is the relationship? It's known as the Fisher relationship or fixture relation. And it is that the nominal rate that we work with, or the nominal rate as a factor, is partly, it's the real rate adjusted for inflation. So the real rate is the real price or opportunity cost of borrowing or of lending. And it's the price of borrowing. You can think of it that way. And we haven't talked about it till today, but this is how you get one from the other. And I mentioned also that in economics, you will have learned that the nominal rate is equal to the real rate plus inflation, but that's just an approximation. It's an approximation that is accurate when inflation is like less than 1%. Okay, so we're going to use this to be precise, the Fisher relationship. So we're going to solve now the first part. Present value at time 0 of $1,000 at the real rate of interest and 1 minus 1 over 1 plus the real rate. So the real dollars must be discounted or valued using the real rate of interest, and this will be for 6 periods. All right, so what is the real rate of interest? I'm going to use this relationship to find it. So it's going to be 1.08 from the top is equal to 1 plus RR and then 1.02. So what we do is we deflate the nominal rate to find the real rate. So everything looks like like the same. You just have to be clear what you're doing. I'm going to put this as like it looks like a discount rate, but it's an inflation rate. And then I have to minus 1 to find the real rate. So do that and tell me what you get. Whatever you get, store it in your calculator, because you need to use it What do you get? So 1.08 deflated is this minus 1 gives me the rate. Right. Now, you want to store it for use in the time value of money third row of your calculator, so you need to times it by 100. Then you store it. So, we're going to multiply by 100 and then store 1. This is equal to 0.058824, blah, 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 right? Goes on and on. So this is our rate. And to get it, we had to deflate the nominal rate to find the real rate. Now, if you put this as your times 100 in storage, you can find this answer. So I'm going to use $1,000 for 6 years, right? I'm going to, oops. So what I'm going to do is put this is store 1, and then I'm going to put 6 years, recall 1 into interest with all those decimal places. Payments are 1,000, and I'm going to override FV to compute PV, and that is the answer. $4,935.55. And you can round now because you're done. So, questions so far? Now about B part. We should be able to get the same answer in B part using the nominal amounts with the growing annuity, where notice the first cash flow is what I need for my formula, and 1 period of inflation has already transpired, so I need to use that amount in the growing annuity formula with the nominal rate. I mean, I know what it is, I can just put it in there, but I'll stress the point. So it's the nominal rate minus the growth rate, right? That's the growing annuity formula. And then 1 minus 1 plus G over 1 plus the nominal rate for 6 periods. That formula should give me the same answer. So let's put the numbers inside and then punch it in together. So I could put 1,020 just to make it easier. And then this is 8 minus the G. Well, the growth that happens is the inflation of 2%. And then this is 1.02, 1.08 to 6 periods. So that's the formula. And now you should be able to punch that in and get this exact same answer. So nominal dollars with the nominal rate, real dollars with the real rate. Let me know if you can get it. So let me see. I'm going to work through the steps for people who still not sure about the growing annuity. So 1.02 divided by 1.08 equals to the power of 6 equals, change the sign, plus 1 equals, multiply 1,020 and then divide by 0.06 equals. So what did I do? I summarized this as 0.06. So in a test situation, all you have to show me is this formula with this answer and this formula with the answer. Good, you got it. Very good. All right, so conclusion, nominal dollars discounted at the nominal rate, real dollars discounted at the real rate, and these will help you convert nominal to real or backward or otherwise, vice versa. So how about question number 2? In question number 1, we began with purchasing power being retained and referring to those amounts as real cash flows to express that our cash flows are going to be adjusted for inflation. In the second question, it's not the case. In the second question, you are told about cash flows that are nominal, so $500 nominal cash flows in the presence of inflation. So it means that We are aware then that the $500 will be worth or have lower purchasing power over time. So we want to calculate, being aware of that in the presence of inflation, we want to calculate the present value using the real discount rate of 5%. For the first part, we want to use the regular annuity formula with the nominal amounts though. So to do that, we need the nominal rate from the real rate. So how do we do that? Okay, bye, Sophia. Buen día. All right, so we need to first find, well, let's first draw it. How about that? Let's first draw this. Oops. Let's draw on it. So it's 5 payments. 1, 2, 3, 4, 5. 5 payments of $500. And to be clear, I'm going to put at the top that these are nominal. And now I want to calculate the annuity with the regular formula using $500 and the nominal rate. And this will be for 5 periods. Right, so I need the nominal rate. How do I get the nominal rate? I know that there's a relationship between the nominal rate, oh my goodness, and the real rate that looks like this, and this is a precise relationship. And I want to find from 5% a real rate with inflation of 2%, no, 1%. Inflation, I want to find the nominal rate. So this is not so hard. I need to inflate the real rate and subtract 1. Okay, the nominal rate is 0.0605. Or 6.05%. So I could write that in here. I can just use the calculator. I'm fine with this. I'm fine with this as long as you have a calculation over here. I'm not going to write more. I don't want to confuse you. So we'll leave it like that. And then let's put it in our calculator. So it's going to be the regular formula. It's 5 years at 6.05%. The payments are 500. Let's override future value because I want the present value. So there it is, 2103.32, final answer. So the answer is 2103.32. Questions? Now, just like before, we should be able to get the same answer using the real rate that they gave me and the real amounts. So we need to compute the real amounts and use them in the growing annuity formula. So what will that take? Let's create that timeline for real cash flows. So what you have are in real terms, what would the first cash flow be? Who's there? What would the first cash flow be in real terms? Go back to the above and see what is our, from the very beginning of this discussion, we had this formula. So I'm going to take it down there. I'm going to take it with me down there. So we have it here. Clean it up a bit. Oops, I'm gonna make it big. No, it's not gonna work. I gotta clean it. Clean all the stray marks. Okay, so from this formula, what is the first cash flow? Well, if I want the real amount, I have to deflate as many periods of inflation that transpired. So for the first amount, yes, very good, Miss Al. So the first amount it seems to be connected. All right. So the first amount will be $500 deflated by 1 period of inflation. The second amount, so they're going down, right? That's what we anticipated because these were nominal amounts not adjusted for inflation. So the purchasing power, which is reflected in real cash flows, has dropped each year more and more, declining. So those are the real amounts. Now I want to use the real annuity formula. The growing annuity formula, which looks like this. It looks like C1 R, and we're going to use the real rate minus G over 1 minus 1 plus G over 1 plus R. I have to use the real rate, so that's why I keep writing that to the power of 5, and that's what I need. So the question is, I know what C1 is. C1 is this amount here. I know what R is because it was given to me as 5%. What is G? So what is G? Oh, I should put that this is N or T. Oh my goodness. I'll put that as T, and we know T is 5. So the only thing we don't know is G. What is G? Nobody? The question was, what's G for the formula? No idea? Okay, let's take a moment. Let's go back and look at the timeline for the growing annuity. The timeline for the growing annuity, oops. Looks like this. C1. So one period before our first cash flow, and then the growth kicks in. And then you have growth until the end. But growth is delayed by one period. It's just there's just the first payment in the first year and then growth. Now we got to look and match what's happening here with what's here. So C1 will be this whole term. That's fine. So where in here is C1, and what does that leave for G? I want this to mimic this to identify what G is. Now, you might think, is G just, because the growth is not positive, This is not increasing, these are decreasing. Someone might think, is it negative 1%, like negative inflation? Nope, that's not what it is. I mean, that's an approximation, but it won't be precise. You won't get exactly the same answer as you got in A. But it's close to the right answer, what G is. So let me show you. If I take this amount and I say this has to be this amount, I need to make it look like that, where C1 is this portion. So let's see, let me take that amount, 500, 1.01 squared is the same as 500, 1.01 with one factor beside it, right? That would be the same thing. So isn't this C1? So this is the C1, and then this is 1 plus G. So it turns out that you can find G using this formula. So I promise you there would be one more formula, and this is it. Actually, wait, let me do the 1 minus. Let me do it like this, or minus 1. This is the third formula for this handout. Okay, I need to connect these. Let's do this way. So what I did, to recap, I need to find my G for my formula, and it's not exactly negative pi. Yes, they are going down in value, in amounts, but it's not exactly negative 1. So what is it? Well, this is C1, and C1 is here as well, with an extra factor, deflation, right? An extra factor of deflation. So what I actually have here is C1 and 1 plus G. The growth rate will be negative when you solve this. You equate these and you get this. Let me make it even more clear, because that's not so perfectly clear, that this is minus 1. Because it was 1 plus G. So if you solve that, you'll find G. So let's do that. This is 1 over 1.01 minus 1 is G. And what do you get? Almost negative 1%. Okay, but it's not exactly. So we're going to store this in 1 now to be used for our calc. Excellent. Thank you for staying with me here. Very good. All right, so let's store that. And what we're going to do is use it in our formula. So let's write out the answer, because writing the formula is not going to get you any points, right? So we're going to write the answer. You could put 500 divided by 1.01 here on the top. And then I'm just following here, this formula. And then the real rate is 0.05 minus, just write G because it's going to be too messy to write out all those decimal places. And then here as well, G, and then 1.05 to the power of 5. Okay, so the real rate was given at the top as 5. So this is my formula now. And to enter this into the calculator, take your time. Let me show you what I would do. I would start in the brackets and I would say 1 plus recall 1 equals divide 1.05 equals y to the x. 5 equals, change the sign, plus 1 equals, and that will give you the entire bracket, the square bracket. Then you want to, okay, so then this is a little bit messy. You have to use some brackets. Let's just figure it out on the side. How about that? So this one is going to be 500 over 1.01. As long as there's no decimal places, you can use that. Too many decimal places. Okay, we're not going to do that then. So what we're going to do is, because you can't round. If you round any intermediate calculations, you're not going to get the precise answer. So what we're going to do is then multiply by 500 . Oh, let's use brackets. Multiply by open bracket 500 divide by 1.01, close the bracket. You can say equals, and then divide by, you can open bracket, 0.05 minus recall 1, close bracket, equals. Or if you have another technique, use it. But that's, let me see if I get the right answer. If I just follow my steps. Just in time, the construction is started. Oh my gosh, I hope it doesn't continue. So, I mean, at this point, you can just store that as this one. I stored this in 1, going to store this part in 2. So after that, I have this whole bracket, the square bracket. But then I continue, multiply, open bracket, 500 divided by 1.01. So it takes a little bit of time. Close bracket equals divided by open bracket 0.05 minus recall 1. It's really important to leave the negative decimal value in storage to get the right answer. And you see, you get exactly the same answer. And I have no room to put it, but I will put it somewhere. So this is exactly equal oh no, this is not good. Okay, so I have no room. So that's it. Unless you guys have a question, practice, practice, practice. You can use the practice exercises from Connect or repeat these problems. Final answer is 2,103.32, just like part A, question 2. All right, very good. So yeah, it's challenging. This is probably the most challenging thing you've done with the calculator, but it's just a matter of practice. So it's 1 o'clock and I'm an hour over, which is fine. I'm fine with it, because I wanted to get through all the material for the test, and that is it. So I'm just trying to think. I mean, that's all you really need. I'll send you test questions similar to these, so just be comfortable with all the material you have. Okay, if you have any questions, contact me, but obviously I'm not going to give you test question answers. But if you have questions over the weekend for clarification, let me know. Okay, you can text me. Putting my number here. All right, it's in the chat. So otherwise, have a great weekend. And the test shouldn't take you all weekend. It should only take you maybe 2 hours, 2.5 hours, okay? But if you want to take longer, that's your prerogative. Okay, so have a good weekend.